There it is. Welcome everybody to SQL Friday. This is episode 8 and our star for today is Josef Richberg, who is not Richberg, Josef Richberg. He is situated in Pennsylvania, which means it's almost still night for him. It's 6 in the morning. So I'm really thankful that he stood up early to join us. As usual, if you have any questions, post them in the chat and I will try to interrupt Josef on a convenient place in the presentation with them. And if you have an answer to a question in the chat, please feel free to use the chat to talk. Their session is being recorded and it will be available on YouTube and on SQLFriday.net, embedded in if you look in the past sessions link. Thanks for coming, Josef. The stage is all yours. Just take over the presentation when you feel comfortable.
Oh, thank you so much, Magnus. Yeah, it's early, but I appreciate this opportunity to speak to people, as well as to help teach other people what I've done. So I have part PowerPoint and part actual code. So let me see if I could share my screen. And hopefully you can see the PowerPoint.
It's coming. Yeah, I see it.
Excellent. So my name is Josef Richberg. I'm a senior data architect at Penguin Random House. I think we are the #1 English language publisher in the world. A little background about myself. So I've been in the business 29 years. I started way back with Informix in a small publishing house, gravitated to Sybase, worked for Sybase in the professional services and the consulting and the education division. Then I got dragged back into publishing and working with Microsoft SQL Server, which actually was born from Sybase. And that puts me here. So SQL is my primary language. Along the way, I picked up various other programming languages, C#, Java, C, C++, whatever was needed for the job. So what I'm going to go over today is the API we built in Azure using all Azure products to help facilitate an in-house program we built. So what an API looks like. So our API was designed specifically to help an application we created called Power Search. So being in publishing, we have, I think, 1.2 million books we have published or are publishing in some aspect. Now, users need to find various pieces of information, and we have, I think, probably over 100 different pieces of information of various books. So what they would do is they would use this Power Search tool to find a collection of books, ISBNs, or we also included things like payer accounts, sold to accounts. And they take these lists of accounts and they use them in various other systems. So we decided to back-end this application with a database, and we can use it to share this information. And then the next step was, well, if we're collecting this on a transactional basis, why don't we use an API to both send this to the other systems and integrate it, and to collect it and store it? So we decided to use a database, which a lot of people for APIs think, ooh, that may not be good. But I'm going to show you some of the benefits of using a database. So here we have is an app service. So think of an app service as a specific size VM that you purchase from Microsoft. That's your service. You can scale it up, meaning I can get a larger size machine, and I can also scale it out, meaning I can have more machines. Now, you've heard the term serverless. You can go or consumption-based. And what that means is when your API is activated, Microsoft will go out, spool up a machine, start your service, handle the requests, and then after about 20 minutes, it'll shut your service down. And that 20-minute shutdown is the problem. Right now, it's only in the US. So 8 o'clock in the morning to maybe 7 or 8 o'clock at night, people use this. Then they go to sleep. The service gets shut down. When the people come in the morning, we saw upwards of a 20-second delay for the first set of persons to use the API. And that's a terrible user experience if you happen to be the first person using it. So we decided to go and actually purchase a specific size server. So that's what a plan is, the size of the server that you want. And here are the tiers. So when you get an app service plan, you have three choices. You have, and they're basically one virtual or one CPU, two CPUs, and four CPUs. And then that's the memory. So they use ACUs, which is it's their overall combined metric. Just like in databases, they use DTUs for database transaction unit. So as you can see, they double, right? I have 210 for my first system, then I have 420, then 840. Now, interestingly enough, if you look down below, these are some of the interesting features that I really like about using service tiers. It will automatically scale out. All you said is how many services you want. So this is it, right? So I decide we have an EP1. We're not sure how large it's going to be. So I go into the scale out. Look, I can scale out to 20 instances, and I can burst to 100. So if you have an API that's at 20 standard instances and is bursting to 100, you're doing a great job. I mean, that means you have hundreds of thousands of people, or you have bad code. So got to make sure your code's efficient. But when people say, oh, what about scale? You can easily scale. So that's never a problem with that. And we generally have one minimum instance, and we don't burst right now. Because what you're going to see later on, another benefit of using Azure as an ecosystem, is this instrumentation, which is going to flow through everything. It goes from your app service to your app plan to your application, your function, everything. And this instrumentation enables you to really take a deep look at your services, see what may be trouble, like what may require work or what's really getting hit. So hopefully at this point, people are beginning to understand what the API is and how it's being used. But by all means, Magnus, you can stop me at any point and I can answer questions. Usually it's good like that because people have some thought in their head. And if you wait too long, either they may not remember it or it's something that I may forget. So you can just interrupt me. It's easier. So that's an app Oh, good. Anything?
No, nothing so far.
Okay.
So
that's your service plan, the size of the machine you want to host all of your services on. Now, one of the other things you can do, and this is specific to the app service, is this little highlighted section here, the scale out of the service. So what I'll show you is you can have many app services sitting in an app plan. Some may be used more than others. Think of it like a garage with many cars. You may really like to use one or two cars often. So those you're going to keep up to date. Full tank of gas, have the oil changed. Whereas other cars, you may change the oil once a year, not keep a full tank. So this enables you to say, great, I have certain number of app services. Which ones are hot and you always want to have scaled and warmed? Because if I have a minimum of, say, 2 instances, but my scale out of pre-warmed is 1, what'll happen is when my app gets so busy that Microsoft determines another instance is needed, it then creates a copy and starts it up, and you have that 20-second delay problem. So you want to keep in mind, if you decide to say, we're going to have a farm of 5 app services or app service plan to begin with, make sure that you also go in and tune your services. And this is kind of what it looks like. You have your service plan, which is a static server that you buy. And then within the plan, you can have multiple app services. There really isn't a limit that says you can have 3 or 4. It's going to be based on memory usage. So let's say, for an example, you have a gigabyte of memory on the server you selected, and your app services take 1 meg. I could have 1,000, right? I mean, you want to look at runtime. So let's say the runtime of a given app is 100 meg at full speed. Okay, I could put 10 different app services on the same service plan. And that's what we do. We actually have multiple APIs that serve different functions. They're not even related, but we put them on the same app service plan because why not? It's just a host. It's a garage where you put your cars. And then this is really the universe, right? So you have your service plan that you pick. Then you have services that live in the plan. And then the app service is tied to a collection of functions. Now here is where it gets a little different. So in C#, which is what I built this in, I have a project. Within that project, I have 7 API calls. Those are the APIs that service the Power Search app. Those 7 APIs are one app. There are 7 function calls. They're one C# project, which means they're one app. So if I change one of those functions, I publish the entire project. That is published to an app service, which is just a container. It's a virtual thing. And the app service says, well, where do you want me to live? You live in the service plan. So hopefully that makes sense, because that's key to this. It's a little confusing in the beginning. So if you did Python or Java, you would want to make sure all of the functions for a given project live in an app service. And then you don't have to duplicate it. That app service, as you saw, can duplicate itself based upon the service plan. And that's what I put here, right? You have your service plan, then you have a service, and then you have a function app. And if you have that in your head, then APIs become super easy. You can group them, you can manipulate them, and you'll see that. So hopefully that makes sense to everybody. Okay. So I'm going to show you the API train. Now, this API train is both a concept, but it's also that instrumentation. So you're going to see this grow, and all these widgets are provided by Azure in the application insights. And as you connect each service, which I'll show you how to do and how easy it is, Azure in the background automatically makes these connections for you. And that's one of the real things that I love about using Azure. So I never like to reinvent the wheel. I'm too old for that. I love programming, and in the beginning, I'm like, oh, that's a library that someone has. Well, let me see if I can do that slightly better. So you'd find the documentation in Python or Java, and you start tearing it apart. And at this point, I realized a lot of those libraries are good. Why reinvent them? So for us, why go and have all these open source pieces? For us, we have licenses for Microsoft. So you could very well build this in your own open source concepts, but this is why I use Microsoft. And if I'm using Microsoft, I'm going to use every piece and show you why it's good. So the database. Remember I said it's back-ended by a database. There's a reason for that. The reason is it's fast. We happen to use a hyperscale, which is a 24-core machine. I think it has 124 gig of memory and unlimited storage. It's a monster. That monster is where all of the data is collected. So as you can see, I have 3 real reasons why a database is very useful for an API. First of all the logic that you need to collect or store your data is done at the database level in a stored procedure. I love Microsoft stored procedures. You keep the database code close to the database. You keep the display code close to the display. So what you're going to see, I'll show you a stored procedure. You don't want to do any formatting. And Magnus and I were talking before how you can manipulate JSON inside of SQL Server. Yes, you can. But we're also explaining there's really no native functionality to store it as a data type. You have to do manipulation. And you may be like, oh, I should do that. I would bet against that. Why? Because the database doesn't do it effectively. You can't join things with it. It becomes very complicated. So all you want to do in your database is store and then retrieve the data as fast as possible. That's why you do store procedures, because the bonus of that is cache. So a lot of times when people are building APIs, they'll use Redis or some other cache to make the calls faster. SQL Server gives you cache for free, meaning if you call a store procedure with a set of parameters, and then later on someone calls a procedure with a set of parameters that has the same information or similar, like let's say I pull 100 books, ISBNs, and later on Magnus comes in, and in his request, he's pulling 30 that are 30 identical ISBNs. Well, if they're already in memory, SQL doesn't have to do a disk I/O. So there's your free bonus, cache. So that's why I love using databases. And it's transactional. So I guarantee they work. And then when this data is used in other applications, when those lists are pushed, they're fast. If someone wants a list, as soon as it's been created, again, memory. This is what one of our store procedures look like. Now, the other benefit of store procedure, it is impossible to do SQL injection in a store procedure. Just not possible. Because I'm not passing any SQL statements. So a lot of times you'll see at the front end, you'll code your select or your insert statements into text fields, and then you'll compile them. Well, that is prone to SQL injection. You have to make sure that your application and your site is completely locked down. I don't like anything that's 100% on the front end because things change. New bugs happen all the time. However, you cannot have it in the back end because you're not passing SQL. That's one. The second thing is this line here, execute as owner. So another security level is the application ID that the API uses. So I give a specific database ID to the API, and I tell the API, when you make your call, you have to use this ID. And that ID has only one set of permissions, execute. And all it's allowed to do is execute 7 stored procedures. It lined up nicely. I have 1 stored procedure per function. And then I have stored procedures call other stored procedures. So I don't have to have a half a dozen stored procedures embedded in my function app. It calls one, and then that goes on and can chain them. What this execute as owner says is, hey, whoever has the permission to call this is granted temporary permission on whatever these objects are. So the API inherits ownership and can then connect to all these tables. So I don't have to grant each table permission. And if you were to actually hack the IP, if you were to actually get the username and password somewhere from the API and you connected to SQL Server, you wouldn't see anything. You couldn't query anything. You would have to know the names of the procedures, and all you could do is pass in information and get information out. Again, a great security feature. And then the one other thing you're going to notice is these are 2 separate select statements. So the other benefit is I'm actually returning multiple result sets. I don't need to return a single result set per stored procedure. The function's job will be to format and to present it to the application. So does that make sense to people why I've made these choices and the best practice? If you're going to use a database, store procedures are the way to go. SQL Server, definitely store procedures. There's no reason you shouldn't. This is very efficient. I think the average API call is 20, 30 milliseconds, which you'll see some of that. So this is a continuation of the train. That one instance is the app service, right? It's living in the plan. And as you can see, when I took the sample, there were 26 calls, and on average, they took 19.2 milliseconds. I'm happy with that. I'm not looking for anything faster. And again, because the store procedures are based relationally, they're indexed properly, they're only doing, they're only pulling data back, they're fast. Now we come to the function app. The function app is responsible for making these calls. So the function app is where it has the user ID, the password, and has what stored procedure is calling what, or what function calls what stored procedures. Here's where all the formatting is done, because C# is great at formatting. There are classes to format in JSON. This is how it looks in the function app. So this is the control panel. This is the abstract app. As you can see, I have all of the, let me move this up here, I think. You have each of my API calls, what type they are. I can enable or disable them. I have keys. I have all this access. Here's that grouping. So that goes back to the C# where I have one project and one project is a series. If I wanted to change any one of these, I would have to go into my C# app, make my change, and publish the entire project. Let's go back on this. Now, inside my function app, you're going to have something called a local settings. And I brought this up for two reasons. One, this is where you connect your functions to the stored procedures. But more importantly, especially if you're using Azure and if you're using hyperscale, one of the benefits of Azure SQL Hyperscale is you can have read-only replicas, up to 4 of them. So over here, this is a great little thing. If you tell your application inside of your connection string, application intent equals read-only, when you make your connection to hyperscale, it will look for a replica for you to read on. If a replica doesn't exist, like we do, we don't have replicas, it'll put you to the master. So by doing that, I wouldn't say future-proof, but you enable your application as soon as one of the architects decide, you know what, we need to scale our system, we're going to add a replica, instantly your function apps will take advantage of the replica, meaning you have like a brand new server. We don't, doesn't matter, doesn't error, falls back. And I use 2 different ones. Some of the API requires us to write data, so this is the normal. Some of the API requires us only to read, so I can split my connections. That's a must if you're building against Azure. And I would put that no matter what, even against if you have a managed instance, because again, as soon as you decide to make a replica, it will take advantage of it. So you don't have to worry about it. Now I'm going to show you some C# code. And then I'll make sure if you can see that. So I'll share this. Can you see that?
I can see that, yes.
Okay.
It takes a while, but now it's on.
Okay. So one of the things, so this happens to be the retrieve lists, which is connected to one of the API calls. And I use 2 JSON serializers. I use the system one when I pull the data in, because everything we do is a post. That's one more thing I want to recommend. Posts are more secure than GET. So everything we do is a post. You may think, I'm only getting information. Just put everything in a post. Much better. So I use the serializer from the system to deserialize the data coming in. I found that to be the fastest one. However, to serialize the data going out in JSON, I happen to use Newtonsoft JSON. So I use 2 different ones. But the reason I wanted to bring this to you is the purpose of the function is to make a call and say, I would like this, here's my information, please give me back what I'm expecting. Then the function is responsible for packaging this data. And you do that very easily. I make my calls, then all I do is loop through the results. And it's simple. Here's the name I'm extracting. I put it here. The name, and I just walk down the list. Is it a string? Is it a Boolean? Whatever it is. Then, remember, I had 2 in the example I showed you. I had 2 result sets. Not a problem. Reader, next result set. So I can return however many result sets. You don't have to worry about in your database doing all of these joins to get a single result set. You get a result set based upon what the need is for the developers. You go back and forth. I can give you 1, or you could say, you know what, I recommend, I give you 1, but I'm going to split it up inside the JSON. So you can give them 1 JSON result in an accepted package, but at the back end, you can have as many select statements as you need to be performant. So again, that decoupling of the database and the stored procedure code, almost like another app, gives you that flexibility. Also, let's say down the road, we reimagine the back end, the tables, and we find a way to improve efficiency. I can make those changes and test those changes without having to pull in the front end team and test the front end, because I can test the changes at the back end with my own tests. So again, that separation is very powerful in many, many ways. I would highly recommend it if you're going to do this in Microsoft. Actually, I'd recommend if you do it in any database, but I will especially recommend it when you build your Azure API. And here's here, right. What's the name? What's the type? What's the name? And then I loop. Done. It's very powerful. I love this. And down here, you'll see that's how I connect dots. So in this case, as you can see, I'm asking for a specific, and up here, which I almost forgot, with that RO. So as you can see here, in my command, I use the RO builder. Because I'm only retrieving a list value, this connection will use the read-only if it's available. So remember, when you build this, you can also split them automatically. Again, incredibly powerful. So, any questions so far? Hopefully this has been clear for everyone.
I think it's clear, and I see no questions in the chat. So I think we're good.
Excellent. So let me share again, and I'll share the other screen so you could see it again. Oh, I'll quickly stop and then reshare because sometimes you can't. Okay, here we go. And then I'll pick up from my current slide.
Yep, we see it.
Oh, excellent. So now, once you have deployed your app or your set of function calls, in your app service, you have something else which is incredibly powerful. So many times you need the ability to test a new version. And this new version isn't necessarily a change in the code coming to the front end. You may have found a more efficient way to do your back-end work, your databases. So you say, you know what, I want to make some changes in the back. So you make some changes in the back, you do your test, and from your testing, they seem to be good. Now remember, it takes 15 milliseconds for that one store procedure to run. So it's really hard to do any type of benchmarking to, oh, I'm down to 8 milliseconds. That's hard to test if it's efficient in a large scale. So one of the things you're capable of doing is within an app service, remember that container that holds your application, you have the ability to have multiple copies of your app. So in this case, I would create another C# application, and that C# project would be connected to the new stored procedures. Then I publish it under a new name. So in this case, I named it _v2. So in your workspace, you have your old copy of your project, and then you have your new copy. You publish your new copy, but you don't want to overwrite the old one, and you need a load test. What better way to kind of load test in production? Right? You see a lot of these microservices and they always say, oh, we can load test in production. We just load up new code and say, we're going to shuttle a percentage of our bandwidth. You could do that with an app service right here. So what I do is when I create this, it tells me this is production. And you can say, you know what, here's my new code. I'm going to swap 15% of the traffic to that. And if it works, you just do swap, boop, and it will automatically swap for you. You don't have to bring it down, bring it up. It swaps it for you. That's awesome. And you can have multiple development slots depending upon the size of your service plan. But this is incredibly powerful because I can now A/B test in production. And going back to the instrumentation, you will see this as a separate app. It comes up here. So now, if you look here, let me go back one. This is my app service. So this is the service where I have my API calls. This is the service plan. So this function app you see here as a type is the one you saw in the previous slide. And this V2 you see as a slot and it has this little icon. So this up here is its own project. This down here is its own project. And as you can see, you can start and stop them. You don't have to delete them. You can say, I'm going to stop this for now. We don't need it. It's taking up some, we're going to work on it, but I don't really want to delete it. Up here, we have one that's running. And here, we actually have one function app, but it's actually running as two individual functions. And now the instrumentation will show that. So you don't have to guess, okay, 15% of it. No. It'll show up as the V2. Whatever you name it, it'll show up in the instrumentation. So you could really see and compare side by side if you wanted to, which one is more efficient, which I think is great. It's awesome. And you could stop one of the slots, right? So you see how you go from a service and the service plan work together. And that's why, again, I love that service plan. I create a VM of a size I think I need, and I can just load it up. I don't need to go, okay, we have a new API. Let's go and create a new set of VMs. Let's connect them. Wait till you see how to connect them. It's just as easy. So we go from here, which is the database, to the app service. Now we have the API manager. Now, one thing people are probably noticing is, wow, that's a 19 millisecond call to the database. And then I just about double it inside of the app. And then I just about double it inside when I go to the API. So I went from a nearly blazing call of 20 milliseconds to almost 100 milliseconds. That's a 5 times lag. Yes, it will take. But while it's 5 times slower, it's sub-second. We're still in the sub-second realm. And all of the benefits you get from each of these steps is so powerful. I would never recommend bypassing and just saying, oh, I'll just have my application, the front end, directly call the database. I think doing that, you throw so much away and make things so complicated. I would never recommend that. I just did this to show you, and this is also the instrumentation. I didn't do anything. I simply told it when I created it, yes, I would like something called application insights, please. It's like, no problem. It'll collect all this for you. And this map updates and it changes. You'll see it connects all the dots. So now we come in the train to the manager. And you're like, okay, what does this do? This is where the world talks to your APIs. So if we go back to your API instance, what'll happen is you can have 2, 3, 4, 5 instances, right? And you'll see that it'll say 2 or 3 or 4 as your services say there's load and you have the scale outs. Doesn't matter. This API manager knows how to connect to all of them. So if they scale, doesn't matter. This is the keeper of the keys, the API manager. You will see some amazing functions. Like I love mockups. I don't know if anyone's ever done API development and done things with mockups. Mockups enable you to put a fake API result set. So you talk to the developers. They're like, this is what we need to work on right now. This is the result set we need in this format. These are the data types. These are the arrays. You take a half hour. You go in, which I'll show you. You do a mockup. And then you say to the API manager, anybody who makes this call, just give them the mockup back. Don't worry about what's in the back end. Within an hour, I was completely free to do whatever I needed to do in the back end. It took them, I think, 2 weeks. It took me, I think, 2 days. But I had those 2 days of freedom. I didn't have to go to the back end, make some fake code, give them fake parameters. No, I just gave them a fake front end. Now, how do you push? You have your app. So I created my app in my project, C# project. I have functions. I have my function app. I connected my function app to my app service plan. Okay, now what do I do? Now you're going to connect your function app, to your API manager. Well, how do you do it? I go right down here to this little button, API management. And then you'll see import functions. If I happen to have, and this is another thing, so the API management service is just like the app service plan. It's a VM that Microsoft manages. And you can have multiple app services connected to one management service. So again, I have one service plan that all of my services live in, and I have one manager that all of my APIs live in. It has its own, and it has more benefits. We have yet to need the ability to go to multiple management services. They do have limits, and you'll see that. And if you get to that size, then again, kudos to you, because that means you have a really popular and a large system. But it's as simple. I select the API management service that I create. I select import functions, and this little grayed out enable insights, You always click that. Yes, 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 always. On everything, your service plan, your database, every single thing. If you see that application insights, you want that. That is that instrumentation. Once you make that click and say, here's my function, and if you wanted to, if you had 20 functions and only 10 of them are ready for production, when you say which ones do you want to connect, you can select later on, once you actually tell it, I'm going to connect, you can select the ones you want to publish to the management service. So what that means is, in your app service, all 10 are there. And for testing, you can, as a developer, directly connect to the app service. But you don't provide that to the world. So that's another powerful feature. Once you say, I'd like to connect my API, my app service, or my project, right? Remember, a project is synonymous with an entire app service. Sorry. This is how you create it. So even though you may have an internal name for your different applications, I know a lot of time infrastructure loves to name servers based upon the location, whether it's dev or test. So it's like, this is Azure East US 2 Dev 53789. That's not great for someone. It's not great for a developer, because developers are like, what was that number again? But you can say, yeah, I don't care what the internal number is. To the world, this is what it's going to look like. So you can change the name. So again, this is a great thing. It abstracts your API from the world. And if you wanted to, you can even version it. Down here, you see a little version. I didn't care for the versioning because I think there's like 3 ways you can version an API. One of them is you put it in the header. And there's a more powerful one that I was just reading about where you put it. It's not a token, but it's some other mechanism. But they don't offer that just yet. And so I figured I don't need it. When they do offer it, I'll just reconnect it, right? That's the other thing. If they offer something in the future, you just disconnect it, reconnect it, and you get all those features. I love it. This is part of that instrumentation I was telling you about. I'll zoom in. So let me zoom in here. Okay. So this is the API management service. So it's telling you, what's the capacity of my current service? How many requests do I have? What, if any, errors did I have? How long did the average backend request take? What is my overall request? So at a glance, you go to your management service and you can see all of the APIs in the service at a quick glance. So you don't have to go and say, oh, how is this API? How is that API? You can use this to get all the general information. And if this were live, and the reason this is partly or mostly a PowerPoint is we have a lot of information. And again, for security, if I were to go through, we would have, not that you can get names and do anything with them, but a lot of people in infrastructure would prefer, especially since this is going out to the world, not to give any hints. That's why. But you could click on these. They're all interactive. And you click and you can drill in. Now on the left, look at this. This is what the API management service, just the management services, provides you. Here's where you click that, it will show you all the APIs connected to the management service. I have subscriptions, which I'll show you in a moment. They have a portal. So a lot of times you develop an API, you have all this documentation through Swagger. You did your job. You're like, okay, it's fully documented. How do I give this to the company? Do I point them to a wiki? Do we have an email? Do we use a Slack channel? No. You create a portal. It's really cool. I haven't been able to do it because it's graphical. But you can publish this to a portal, and then the portal can have an external and internal set of pages. So when you log in with your AD credentials, you would go to the internal developer portal, which would have things like, oh, here's the server name, here's the code repository in Git. Then so all of our stuff is internal, but if you also wanted to publish some APIs to external clients, you would have an external view. Super powerful. And here's your analytics, and this is the application insights, which gives you those nice graphs, the little bar that shows you that API train that I'm showing you. Let me see if I could zoom in with that. Oh, I can't zoom in anymore. There's your locations. This external cache. So let's say you happen to have an API that, yes, the database calls are used, but you have a lot of data which, once pulled in, is used by universally. You can connect a Redis gateway in a Redis cache in Azure to your manager, and your manager will go and say, oh, this exact call was already made. Boop, I'll give it to you again. So those layers of services give you at each opportunity new ways to improve the overall performance. So if I decide, hey, the APIs we have now don't need Redis, and then in a few months, we create a brand new API, has nothing to do with what we're doing now. Okay, I'll give you the gateway. The app service plan has plenty of space. Put it on that. Oh, you need Redis? I don't have to throw my infrastructure away. I just go down here to my external cache, which is down on the left. Hard to see the cursor because it's white. And I set it up. So again, these layers provide power at every single step. So let's go back. Let's see if I can. Okay. So let's see if I can go to the next one. There we go. So keys to the kingdom. Now, remember, you have the database, which is connected to the functions, and the functions know the user and the password. You cannot directly call the functions. I didn't give you a key. The functions then live in an app service. You could call the app service directly. I didn't give you a key. When I connected the app service to the API manager, as soon as I did that, the API manager goes, oh, I'm going to create a key for myself. So now what's happened is no one can directly access your functions, and no one can directly access your API. Only through your API manager. You give your API manager the key the manager creates to the front end. And you have a choice. In this case, I have said I want a specific key for each API. If you happen to have multiple APIs that all were accessed by the same front end, you could say, I want to create a product, and you can call it, my super API. Tell the manager these 5 app services are part of your product, and give a key to the product. And then the API manager says, oh, you have access to any of these calls. Again, security. I'm big about security and performance. So as you can see, yes, you've gone from an absolute 20 millisecond call to 100 milliseconds. But you would not be able to reproduce all this. And even if you spent the time and effort to reproduce all of this functionality, you would have longer than a 100 millisecond call. And why would you do that? These are all available to you. This is the app service, right? So we were here at the API manager. So it's created keys for the world. Now here is your app service. There's a master key. And then there's this API M. This is created by the API manager, right? So when you say I want to connect this app service, it creates all these keys. You don't have to do it. You could create a key here and directly connect to your apps to your front end. I wouldn't recommend it at all. Even internal applications go through the API manager. You don't want to short circuit that. But if you wanted to, you could. All done for you. Again, I love this instrumentation, and this is why I love Azure. It's an ecosystem that is interconnected. All you have to worry about and use your imagination for is, what do I want to do today? Now, even more power of the API manager, right? Behold, the API manager. So you saw all the functionality from the instrumentation where you could, in one shot, see all of your APIs and if there's any bad actors. This enables you to do that inbound processing. And this is where the mockups I was telling you about. Now, this could be done at the API level, which is what's here. Or if I went one step up, I can do this at the API manager level. But I would recommend it at the API level. And even more important, the mockups are at the actual call level. So each of these posts can have its own mockup, which is what I did. So if you were to go here to inbound processing, you would see this. There are 3 things that I think are fantastic about this. you have the mock responses, which I talked about. Again, I click there, I say, here's my mock response. I can do what I need to do. You also have and then what you do is when you're ready and you publish your app service and everything is good to go, you go back in and you turn it off. When you create one, it's an on or an off. You also have limit rate and set usage.
I think we lost you for a few seconds there, Joseph. So can you just repeat the last sentence?
So one of the things about mock response is you can turn it on and off. Once you set up a mock response, and again, the mock response is at each of these calls. Each post can have its own response, which it should, and you can turn them on and off. So if you have 5 APIs you're working on, you set 5 mock responses. The front-end developers get to go on their way and do as they see fit. You get to do your work. As your APIs come online, you go in and you simply go flip it. You can tell the developers, or you don't have to tell them. You can flip it on or off. Now, the other features that I like is this limit rate call and this set usage quota by key. Let's say that your API is getting hammered by one front end. So let's say you have 3 or 4 applications that use your API, and they're in-house applications. And all of a sudden, this new application comes online, and it's just terrible. In a sense, it's really making more calls than it should. You weren't contacted, they developed it, it's now quote-unquote live. So you can't turn it off. What you can do is you can limit the rate by key. So what you could do is you could go back to your subscription. You can manually create a specific key for that front end, give them the key, and then you can say, I want to limit calls per second. I want to limit, and when you do the limit of calls per second, you can say it's by IP, it's by key, it's by subscription, and you can say, here's how it resets. It resets by time, it resets by number of calls, like after you get a certain, like an OK, or maybe you want to say, I want this to reset when my server tells you a 400. The same thing for set usage. Do you ever go and you purchase a key from a company and all of a sudden, after a period of time, it stops? It's the usage quota. You can say they can only have X number of megabytes in the lifetime. They can do X number of megabytes per download or per 5 minutes or maybe per day. Sometimes there are a lot of API. I think the New York Times that we have here has a limit per 24 hours of calls. You do that all through the manager. This is ridiculously powerful, and it's just clicks, click, 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 click. Per API, per call. Again, why would you pass this up? Let's see if I continue on. Then the last thing is your diagnostics. Here is where I tell the API manager how often to collect information. Microsoft recommends a 50% sampling. You don't want 100% sampling unless you're in development where it's getting all this data, because it does put a load on your API manager. You've got to remember, it is a server by itself, so it does have limits. But look at what I can do. I can tell it in my application insights, I want you to do a 50% sampling. But notice for high traffic, you do 50% because for high traffic, it can cause a problem, but always log errors. So this is, hey, I'm going down the normal road, and if there's any errors, it'll automatically log them. So don't worry about, well, I want to make sure I catch an error because errors are important. This always grabs an error. And then you can put how much information do you want. And you can change this at any time. And if you wanted to, you can connect via OAuth 2, OpenADI, or OpenID. Again, this is internal. So what happens for us, which I'll show you here. Oop. There we go. That's the last slide. This is the train. So as you can see, this is the front end. Now, just so happens, our front end was written, it's in React, and it happens to live in its own app service plan with its own app services. So app service is a misnomer. You can put your web app in an app service and an app service plan, and then you put your functions in an app service, which lives in an app service plan. And if you do that, and it's completely in Microsoft, you get this nice little train. And I love it. It tells you what's making what call, how long it takes, and this is live when you go to it. And one more thing I want to bring up is this here, Azure Search. Let's see if I can get my mouse. So remember I said there's hundreds of pieces of information that users wind up looking for. So again, this power search is, I want to collect a series of ISBNs or books that I want to manage. I want to take this set and I want to use it throughout other apps. Well, those 100 pieces of information, and there are various pieces, I think totals 10 gig of data, because they want to search for a city, or maybe they want to search for a category in a city, or a name of a bookstore. So that could be done by the API, and we thought about that. And then we realized a database is not really designed to do searches across massive amounts of text data. Databases are great for point and shoot. So we figured, what would be a good service? Azure Search. So our application, our ecosystem works like this. Someone logs into the application using Azure credentials, AD credentials. When they connect, the database looks up the user and says, does this user have a preference for the screen? Because remember, with over 100 different pieces of information, that could be overwhelming. So you can go in and customize and say, all the time, unless I tell you, I want these 5 pieces. That's stored as a user profile. So when you log in, it validates you, and then the front end, once you're validated, passes the information and says, please give me the preferences for this user. Then that's the right part. Then the user goes in and makes searches and finds the ISBNs they want to manage. That's where the database comes. It saves it. But not only does it save it, it saves the structure. Then the next time they log in, it'll pull back the list and it'll pull back that structure. And going back to JSON, this is interesting. The front end that they use has JSON structures for everything. So when a user says, here's my list, here's my preference, that structure is saved in a text field as a JSON object. When they log back in, I just pass the JSON and the front end can then decompose it and you get it. You get your entire screen the way you left it. More importantly, as you select, like you may have a summer reading list with 100 ISBNs, and then you may have a summer I want to follow list with 20 ISBNs. If you make those lists public, meaning other users of the app can see it, because sometimes one person in a sales department will make like a 2020 summer watch list, and everyone in the department wants to watch that. So one person makes the list. That list is a public list. When they go to other applications, they go and say, I would like this list. It goes to the API through a different, right? It'll be a different front end, but through this and collect it. So that's why we did it that way. But the thing to keep in mind with an API is it doesn't have to be all or nothing. You can split your ecosystem up. Without this search, the API is useless. But without the API, the search data is overwhelming. So hopefully you got more than just a tunnel of this API has to do this. It's an API is going to serve a purpose. Here's how I build my API ecosystem because I want everything else to use it. Like we want other apps, if they want this data, use our API. Don't go to the database. Don't go directly to the app. So that's basically it. Hopefully I didn't go too quick, and hopefully it made sense to everyone.
I think it did.
Oh, I'm glad.
Cool overview. I told you before, I work in for the moment in the insurance industry, so I wouldn't say we're completely in Azure, far away, but the discussion is going on, and I think there are so many things that will make life easier if we can just go to a cloud service, and Azure would be the choice, I think, because there is so much built in, and any company that is interested in security, it's all there. We don't need to invent anything. We don't need to make the mistakes because we can't make them.
Exactly.
Well, of course you can make mistakes, but there are so many things that are mandatory. You can't just override it because it has to be there.
You kind of have to consciously run around the things that they're doing for security. And interestingly enough, when we had the front end, we have pen testing that they do. When the pen testers went through this, it took them a week. They found 4 concerns. One concern was that they're passing too much information to us in the header. We have them pass some additional information in the beginning. Now we can change that. So we're like, okay, we can change that. And we're going to encrypt it. We're going to do certificates, which that's the other thing, because these are actual stand-up servers that you purchase, right? It's not a serverless consumption. You can put certificates on them. So there you have HTTPS. The other 3 concerns were around the app not properly exiting from Active Directory. Like, I could go to your machine, you go into your application, and then you close your browser, and then I come and sit down, and you're like, hey, I want to show you something. As soon as you open your browser, I can go back into your session.
Okay.
That was because the front end never timed it out. They could not find a single way to get into any, and they had access to the API manager, they had access to the app service server, they had access to the database and the function apps. They couldn't get in any. 4. And it was basically the front end wasn't actually clearing cache. The front end wasn't timing out. Not your API is open, not I found a way around this. It was beautiful. So you're right. Basically, if the front end developers do just simple things, make sure there's a logout button, make sure you don't cache things, and you authenticate, and they authenticate against AD. And believe me, it is much simpler for the front end to authenticate than the back end to try to call, because that's a nightmare. It was easy. And you leverage each step for the power the step provides. I love it. It's so nice. And when someone says, hey, can you do this? Half-hour research. Matter of fact, yeah, another 15 minutes. I stood it up. Now let's start playing.
Yeah, it's cool. There are so many things that you wouldn't even consider building yourself in terms of security, because it will just be too much work to try to invent that wheel. So
exactly. So
it's cool.
Thank you, and I hope everyone enjoyed it or at least learned something from it. Any questions? Or if not, I don't know whether to take that as, hey, this is great, it was clear, or I'm so overwhelmed, I don't know what to say.
I've got some thank you very much and very well done in the chat. No questions.
Oh, excellent.
I guess if it's new to anyone, it's hard also to figure out what kind of question should I put out there. We have another thank you for the presentation from Marcus. Yeah, and I agree. Thank you. It's
you're most welcome. And if anyone has questions in the future, feel free to email me. I think I put my email up. I'll put that back. It's sqlrunner@gmail.com. I think that's in my LinkedIn as well. Let me see.
Yeah.
Yeah.
The presentation, do you have that available publicly, or could you email the presentation and I can upload it to the site? Yeah.
I'll email you the presentation.
And then all the contact details, I think, was on the first slide. So that's perfect. Yeah. So.
I will email that as soon as we're done here. Thank you very much for this opportunity. Like I said, I think you're doing a fantastic job of collecting this because we need this. I love going to conferences, and it was always difficult to get to them when they're all over the world. But what you're doing, I think, is really good because you're collecting people and knowledge and giving the ability, no matter where you are in the world, to access it. And I love that. I think it's a great thing.
Thank you. Yeah, it was. I've had the idea for a long time. There used to be before Teams and Slack and Zoom and what have you, Microsoft Sweden had something called Thank God It's Friday, and it was purely or Thank God It's SQL Friday. So, but it was purely for a Swedish audience, and there was always some technical difficulties because really the online conferencing software wasn't there. But now it is, so it's kind of easy to set up the calls and do the recording. It's all it's in the cloud, so it's in Microsoft Stream Services. So it's very little technical work for me to do it, and I have an opportunity to learn something and meet great people every Friday. So I'm gonna continue.
I'll look to see if I can put some more things together, and maybe I'll send them to you and see if there's something that'll fit in for others, because I like this. I think this is brilliant.
Yeah, and I just shared the upcoming schedule.
That's awesome.
Actually, also October 16th is booked. I just haven't put it in the schedule. So, but I think we'll fill the schedule with great talks until year end. Then I'm pretty sure I will continue, but my first aim is to get to Christmas and then have a couple of weeks off, and then we'll continue next year. So.
Excellent. Thank you again for the opportunity, Magnus.
Thank you. I'm going to disconnect now and get to my kids and maybe play some football in the rain or something.
Bye-bye.
See you. Thank you, Joseph.